In this video, we're going to tackle the experimental calculations or laboratory calculations for heat of combustion. Now, usually this data is given when you perform a face-to-face experiments for heat of combustion where you're going to encounter alcohol or ethanol as your fuel to combust or heat water. Now, we are given with this data, the mass of alcohol lamp before heating as 160.9 grams, the mass of alcohol lamp after heating as 157.66 grams, and then we have the mass of the beaker at 85 grams, the mass of the beaker with water is at 110 grams, and then the mass of the water, we're just going to subtract 110 with 85, so this gives us 25 grams. And the mass of the beaker with water and lids is at 140 grams. And to determine now the mass of the aluminum foil lid or the cover, okay, 140 grams minus 110 grams, this gives us 30 grams. And then the temperature of the water before heating with alcohol as our fuel is at 23.4 degrees Celsius, and the temperature of water after heating is at 43.4 degrees Celsius. Now we're going to determine the following five parameters, as the first one being heat gained by the water, the second one is heat gained by the beaker, the third one as total heat given off by the alcohol, fourth as energy given off per gram of alcohol, and lastly as the energy given off per mole of alcohol or ethanol. Now we are required to calculate the following five parameters. Now if we're going to proceed now with the solution, first we need to calculate the heat gained by the water or Q water. So to calculate the heat gained by the water, we're going to multiply the mass of the water with the specific heat of the water and the change in temperature. Now let's substitute the following values. The mass of the water at 25 grams, the specific heat of water at 4.184 joules per gram degree Celsius, and the change in temperature as the temperature after heating minus temperature before heating the water. So 43.4 degrees Celsius minus 23.4 degrees Celsius. The following quantitative parameters gives us 2092 joules for the heat of the water. Now let's proceed with the total heat given off by the alcohol is actually equal to this amount as the heat gained by the water and the heat gained by the beaker at 2092 joules. Now, the second step to calculate this problem is to determine the mass of alcohol. Okay? To determine the mass of alcohol, we need to subtract the amounts of the mass of alcohol before heating minus the mass of alcohol lamp after the heating. So this is 160.9 minus 157.66 grams, which gives us for the mass of alcohol used to heat the water at 3.24 grams. Now, the third step is to determine the energy given of per gram of alcohol. So we're just going to divide this amount of heat gained by the alcohol or heat gained by the water, since they are equal, all over the mass of alcohol used for this problem or for heating the water in this problem. So Q alcohol all over mass of alcohol gives us 2092 joules all over 3.24 grams, or this is in 645.77 joules per gram. To determine the energy given off per mole of ethanol, we need to determine the molecular weights of carbon, hydrogen, and oxygen. Why is it so? Because the chemical formula for ethanol is C2H5OH. Now, to determine the molecular weights of the compounds ethanol, C2H5OH, okay? Since we have 2 moles of carbon, 5 moles of oxygen, 1 mole of, 5 moles of hydrogen, 1 mole of oxygen, and 1 mole of hydrogen, this gives us 2 multiplied with the molecular weights of carbon at 12 grams per mole plus 6 multiplied with the molecular weights of hydrogen at 1 gram per mole plus 1 times the molecular weights of oxygen at 16 grams per mole. Okay, these values are obtained through using Google or our periodic table. Okay, summing up these values gives us the molecular weights for the ethanol at 46 grams per mole. All right. Now let's proceed with the final calculation for this problem as energy given of per mole of alcohol. We're going to use this formula. The heat of alcohol or heat loss by the alcohol multiplied with molecular weight of ethanol. In this problem, we used ethanol all over the mass of alcohol or ethanol used to heat water. Now let's substitute the following values. 2092 joules multiplied with 46 grams per mole all over 3.24 grams. This gives us with the final value for the energy given of per mole of alcohol at 29,701.2346 joules per mole.